Welcome to Sundar's lecture. This is lecture number 46, and in this lecture we are going to take a numerical problem that will be RLC circuit. See, we have taken an RLC circuit and we will see the problem. So what are all the topics we have seen in the previous class? See, we have taken the RLC series circuit derivations and AC through RLC circuit. See, we have found we would have seen three cases. One is case 1, that is XL greater than XC, and how the phasor diagram will come, and then we have found what is the impedance value. And we have gone for case number 2, that is XC greater than XL, and we have found what is the value of Z, and so many things we have seen in the previous class. That is XL which is equal to XC. In that case, what happens to the circuit? That will be the purely resistive circuit. All these things we have seen in the previous class. Right now, in this class we will take this problem. Right, we will read what is the problem. A series RLC circuit has resistance of 50 ohms, inductance of 0.1 Henry and capacitance of 50 microfarad connected in series across single phase 230 volt 50 Hz supply, and then we need to find current, power factor, real power, reactive power, and then we need to find the voltage across inductor, capacitor and resistor. This is the question given. I have just drawn the diagram. The question given is resistor, inductor, capacitor in series, so I have just drawn the diagram with the help of this question. Right now we try to find what is the current. Before that, obviously we need to find what is the value of Z. Right, to find what is the value of Z, see, this is the common diagram, and we need to find what is the value of Ez. Right, first of all you need to find what is Ez. So Ez, which is equal to, see, always we will write R plus JXL minus JXC. That's all, because always you see whenever you are going for RL circuit, your impedance value would have been R plus JXL, and if it is RC circuit, your impedance value would have been R minus JXC. Now it is combined. See, we have R, L and C, right? So this is the formula. We can directly write this as the formula now, right? So now you can easily find the value. What is R here? That is 50 ohms. That is 50 ohms plus, you take this J outside commonly, then it will be XL. What is the value of XL? We need to find XL minus XC, right? This is the formula. And if you want to find what is XL, what is XL now? XL will be is equal to 2 into pi into FL, right? So we know everything now. So this is 2 pi into 50 Hz, that is the given frequency. And what is the value of L? L, it is 0.1 Henry, right? So this is 0.1. And if you find what is the value of XL, then XL comes out to be, for me it is coming 31.4159 ohms, right? This is the value of XL, and you need to find what is the value of XC, right? So to find value of XC, we know the formula. What is the formula for XC? That is 1 by 2 into pi into F into C. So if you substitute this value, this is 1 divided by 2 into pi into 50 into, what is the value of a capacitor? That is given it as a 50 microfarad. So it will be 50 into 10 to the power of minus 6. And if you simplify this one, you will get XC will be is equal to, I am getting 63.662 ohms. That's all. We know what is XL and XC. We can directly substitute in this equation. So you will get Z is equal to 50 plus J into, what is XL here? What is XL? 31.4159 minus, and what is the value of XC? That is 63.662. And finally, if I simplify this one, Z will be is equal to, I am getting 50 minus J of minus j of 32.2461 ohms. And this is the value of Z now. And I need to find what is the value of I. That is my aim, right? To find I. And if I go for I, then I will be is equal to V by Z, right? V by Z. So you can convert this value, right? It is very simple to convert from this is rectangular form, and you can easily convert this into polar form, right? So if you convert this to polar form, then Z will be is equal to I'm just getting 59.4963 at an angle of that is minus 32.82 degree ohms. You just see my previous lectures how to convert rectangular form into polar form. That is a procedure to convert this rectangular form to polar form. You just try to understand with the help of my previous lectures, right? Now you can easily go for I. So I will be is equal to what is V here? V always it will be reference to 0. If they are not giving you anything in 230 volt, then obviously the 230 volt will be the reference one. So it will be 230 at an angle of 0 degree. Then this is divided by 59.4963 at an angle of minus 32.82 degree, right? So if you simplify this, then I will be is equal to I am getting 33.8657 at an angle of 32.82 degree. And yes, you try to understand one thing. We have found what is I now. Very simple to understand. See, I is equal to 3.8657. This is the amplitude value. At an angle of, we are getting it as 32.82. Which means the current leads the voltage phasor by some angle, that is 32.82 degree. Then what is this circuit? This is a capacitive RC circuit. It looks like a capacitive circuit because I leads current, right? It is more capacitive circuit. We can say that it is a more capacitive circuit than inductive circuit because XC is greater than XL. So you will get what? You will get obviously the current should lead because XC is greater than XL in this particular circuit. Try to understand. If XL is greater than XC, then you will get a minus degree here. You will get a minus degree here because always in a more inductive circuit, the current should lag the voltage. That is the more inductive circuit. Right? These kind of things and all. Just a hint of tips to understand the concepts in RLC circuit. Right now, you can directly write pi value will be is equal to, here it is 32.82 degree. That's all. Right now you can find so many things. What are all the things? You can easily go for power factor. What is the formula for power factor? It is cos pi. So we will take a new page. Anyhow, I will move this one. So to find a power factor, what is the formula for power factor? It is cos pi, and it will be is equal to cos of 32.82, right? So if I simplify this one, I will get power factor will be is equal to 0.8403, and you have to write this power factor is leading. Since this current is leading, we always write this is the leading power factor. If the current is lagging, then we will write it as lagging power factor. Anyhow, this is the leading power factor. We have found what is power factor, and we need to find what is the value of P now. That is the real power, right? So we will take a new page. So now we will go for power, that is real power. That they have asked you to find real power, right? P, and then we need to find what is Q, right? So if you want to find what is P, P will be is equal to VI cos pi, right? VI cos pi. These are all magnitude values. Try to understand. These are all magnitude values. I have just written the V here. So it will be 230 into 3.8657 into, and we know cos pi, directly we know cos pi, right? So you just write it down directly here. That is 0.8403. and if I simplify this, I will get power, that is real power, that is equal to 747.1888 watts. So this is the real power. And if you are going for reactive power, that is Q, they have asked you to find reactive power also. So that is VI sin pi. We have seen these formulas already. So it will be 230 into 3.8657 into sine of, what is this one? What is the angle? 32.82 degree. Right? So if you simplify this one, Q comes out to be 481.899 VAR. That's all. So we have found what is the real power and what is the reactive power now. So next one, they are asking you to find VL, VC, VR. Try to understand. This one is very important. I have just taken this one to explain you how we can draw the phasor diagram with the help of the expressions, that is VL, VC and VR, right? So we will do that. It will be very helpful to understand the phasor diagram in an AC circuit, right? So we will go for it now. So first of all, we need to find what is VR. Let it be VR, anything, you can take anything, but I am just taking VR. So this will be I into Z. I'm just writing it as Z, but it has to be V, but I'm just writing it as Z now. So that you can easily understand this one. So you see this one here, I into R plus it is J0. See, since why I'm writing this one, I just want to get what is the value of voltage across the resistor, only resistor. So this value I'm not going to consider. So what I am doing here, I have just taken it as R plus J0. So you see, I'm just going to substitute. What is the I value? What is the I value here? It is nothing but 3.8657 at an angle of 32.82 degree into, what is the value of R? That is given as 50, right? 50. Here it is given as 50. So if it is 50, then it will be 50 at an angle of 0 degrees, since it is resistor. Since it is resistor, there is no J, just it will be 0 degree. So if I find this one, I will get VR is nothing but, I am just getting VR 193.25 at an angle of 32.82 degree voltage, that is volts, right? This is the value of VR now, and we try to find what is VL. Try to understand. We do it. It should be understood. You just come with me so that it will be easy. So I into Z. I am just writing it as I into Z. It will be I into. I am just going to put R as 0 here. R as 0, and then I have to put this Z. In this Z, it will be plus JXL. Always it will be like this, right? If it is a capacitive reactance, then it will be minus JXC. Right? So many things. So it will be what? What is this one? So I can write it as, what is I here? That is 3.8657 at an angle of 32.82 degree, and it has to be multiplied by with what is XL? What is the value of XL we have got here? XL is 31.419. XL is 31.419. 31.419 at an angle of, what is this one? This is under J, right? This should be 90 degree. This should be 90 degree. So what is the value of VL now? So VL comes out to be, I am getting 121.44, and if you simplify this one, you will get at an angle of 122.82 degree volt. So next one, we have to go for VC. So if you are going for VC, see, I am just writing it as I into Z, and in this Z it will be I into 0 minus jXE. That's all. Simply you have to put minus jXE since there is no resistor, there is no. I'm just not going to consider the XL value. Only I have to consider the XE since I am going to get what is the voltage across this capacitor. So if I do so, what I will get? So it will be is equal to what is I, that is 3.8657 at an angle of 32.82 degree. That should be in the multiplication of what is the XE value here we have found? XE, that is 63.662, right? 63.662. 63.662 at an angle of, here you see it is minus j. So what you have to put, that is minus 90 degree. So if you simplify this one, I am getting, that is VC will be is equal to, it is magnitude value is 246.09 at an angle of minus 57.18 degree. 18 degree. So see, we have found what is the value of VR, VL and VC. See, it is very simple to understand that V will be is equal to what? VR plus VL plus VC. That is in phasor. That has to be 230 volt, right? That is the given value. It is 230 at an angle of 0 degree. See, if you simplify this, if you add these three phasors, then obviously you have to get it as 230 at an angle of 0 degree. Maybe the calculation errors, we would have taken this as 122.82. Some values will be there after the decimal points, after 2-digit decimal points. So you will get around 229.99, or you will get some angle, maybe minus 1 degree, or it may be 1.5 degrees. Anyhow, so that calculation errors, we have to neglect those kind of things. But if you add these three, you should get that V is equal to 230 at an angle of 0 degree. So what we will do now, we try to draw the phasor diagram now. We try to draw the phasor diagram so that it will give you much more insight towards the problem. So we try to draw that one. So for that, we will take new page. Right. So we have written all the values of voltages and current, right? So what we will do now, we try to draw the reference phasor. I am just going to take the reference phasor as 0. That means I value. Let me draw that one. See, I will take this as the reference. Anyhow, I will do here. This is the reference value I, right? So I will draw like this. Maybe I phasor. What is the value of, we have to draw for the magnitude value, and what is the magnitude of I here? It is 3.8657, right? This is 3.8657. Just I will write it down this as I phasor, right? This is I. And what happens to VR? VR and I will be always in phase. That we know already, right? So what we will do, we just try to extend this one, because this magnitude value is nothing but it is 3.865, right? So anyhow, I will write it down. This value, it is a 3.8657 amperes from 0 degree. See, this is the reference one. This is the reference one, right? This is the reference one. From that, it is angle, that is a 3, maybe I will write it down as you see. I will draw this one anyhow. So this will be some angle, and I will tell you what is this one finally. So this angle, so this angle, that is nothing but 32.82 degree. It makes clumsy, that is why I have not written anyhow. So now we have to travel. This VR should be in phase with the, what, that is why we are getting here also it is 3.82 degree, try to understand. So we have to extend this one right now. So if you extend this one, maybe I will extend up to this point, some value. So this value, which is nothing but it is VR, and VR, what is the value? What is the magnitude value? That is 193.25 volt. So this is VR. Now we have drawn the I and V phasor. Both are in phase, that we know. Anyhow, I will put a mark here. This is the I value. And now what we need to do, we will go for VL now. So this is the reference one. This is the reference one. Maybe 0 degree reference. And VL should be 121.44 magnitude, but at an angle of 122 plus 122.82 degree. So where it will come? Where it will come? Try to understand. So this is the 0 degree and this is the 90 degree, right? This is the 90 degree and it has to be here, somewhere else here, right? So it will be somewhere else here. And what is that value? That is 121, just 121, right? So you try to draw with magnitude values too, because intimate that, see, this phasor is 193, angle of 193 voltage, so this will be 121 voltage. So this will be VL, and that answer, which is nothing but it is what is that one? 121.44 degree. Sorry, not degree, it is volt. So it is the voltage value. So it is voltage. See, we have drawn what is VL now, and what is VR, and what is this angle? This angle, that I will anyhow I will write it down finally, because we need to draw everything. So next one, that is VC. VC is minus 57.18 degree and with the amplitude value of 246.09. See, it is negative angle. It is negative angle, and if it is a negative angle, it will be 90 degree, right? It will be 90 degree in negative. That is, this is the reference 0, and it will be 90 degree, and it should lie somewhere else here, because it is my 57.18 degree. So it may be like this, because this amplitude is very high. I am just drawing this like this. So this value, I'm just writing it as VC, which is equal to 246.09 voltage. Right? This is the VC value. So we have done we have drawn everything right now. So what we will do now, we try to connect these 2 points, that is VR and VC. So I'm just drawing this one. See, so I will connect these points. So it may be like this, right? So this point I have just connected, I have just drawn the diagram, and it has to be like this. And what is this one? And this is nothing but VR plus VC. This is VR plus VC, right? So if you further do this one further, so you try to understand, this is VR plus VC now, and we need to add this VL with this phasor. And if I add that one, so it has to be like this. This is VR plus VC, and I can connect this point now. This one I can connect. See, I'm just connecting this one. So this point, which is nothing but, I will write it down it as this point, which is nothing but VR plus VC plus VL. That's all. That should be is equal to what? Total V. So what is this one? This phasor, which is nothing but it is total V. That is our reference. That is our reference, right? This is the reference. That should be in 0 degree. See, everything is very easy. when you are drawing the phasor diagrams, right? So what is this angle now? Right now you can, it is very simple, right? So what is this angle? This is nothing but V, and what is the angle of VC? So this will be, VC will be minus 57.18 degree. And what is this angle? What is this angle? This angle, it is 122.82 degree, and everything is good now. See, this is the 32.82 degree angle. So what is this one? This one, which is nothing but total V, and this one, which is nothing but the I phasor. This one is total V, and this is the I phasor. And what is the angle between I and V? That is nothing but it is 32.82 degree. So obviously pi value will be is equal to 32.82 degree, and that too this angle is leading now. Current angle is leading. See, this is the I and this is the V, and the current is leading here. So the angle, that is 32.82 degree, which is nothing but it is positive angle, right? So we have got everything with the help of phasor diagrams, right? If you find what is the VL, VC and VR, then you can go for phasor diagram. Try to draw the first I phasor, and I phasor should be in phase with the VR. See, the angle at I will be 32.82 degree, and also VR will be 32.82 degree. So if you draw that one with respect to some 0 degree, I am not just writing it as V. I have not told you this as the V phasor, but we know that one. Since we have taken V is equal to 230 at an angle of 0 degree, then it has to be total V. So I have drawn VL, and then I have drawn VC, and I have tried to connect VC and VR, and then with this phasor, that is VR plus VC, I have just connected the VL. So it is VL plus VC plus VR. That should be the total voltage, and it has to be the 0 degree phasor. Try to understand so many things we have seen with this particular example. We have taken with a problem, and we have found so many things, right? Power factor, real power, reactive power, VR, VL, VC, and at last we have gone for the phasor diagram. This looks very clumsy since I have written everything into it to explain things. I have written everything, but it is not necessary to put these angles because we know that angle here itself. So you just draw the phasor diagrams and you try to understand things, right? So we will go for the next topic in the next class. So you go through these problems and the expressions, you will get a good insight towards RLC circuits with AC inputs. Thank you.